do sharing with you guys. So as Erin mentioned, I'm Lisa White, Associate Director at Phius. Most of my time, I've been with Phius almost 10 years now. Most of my time there, I have been the project certification manager. So I've been really in the technical side, standards development, training programs, and whatnot. So I'm going to get into the Phius ZERO program and kind of talk about the foundation and the things that built up to Phius ZERO. Okay, so first off, I want to give a little bit about Phius for those that aren't familiar, and just a quick level setting. Phius was previously Passive House Institute US. So this is just an acronym made into a word. So that's Phius. If you haven't heard of Phius before, it's just Passive House US. Okay, so we're a nonprofit company, mission driven, and we're trying to address the climate crisis through passive and zero energy buildings that can both mitigate and adapt to climate change. So they can both mitigate climate change by reducing emissions and also adapt through resilient building. We're focusing on conservation first, and I'll get deeply into that, really on the path to zero, trying to define this path to zero. And we just want to make this type of building mainstream. So we do this by certifying professionals. You can see Phius certified consultants in the top left. We certify products that go into buildings, or rather product data that goes into buildings. We work on energy modeling or compliance software and compliance checklists for our programs. We certify buildings. So you see Phius ZERO down there in the middle. And we do standard setting, and we have a membership organization, the Phius Alliance, which has various chapters throughout the country. But today's focus again is on Phius ZERO. And this is a passive building standard that provides a cost optimized efficiency targets, guiding you to the sweet spot in conservation on the path to zero. So if you're going to have this, if you want to get to zero, you invest this much in conservation, passive and active, then turn to renewables for zero, and we'll get into those details. Okay, so a little bit of history and principles before we dive into the standards. So let me move my video real quick. Okay, so just a little bit of evolution. The first kind of the passive building principles and concepts started in Urbana, Illinois in the mid 70s. They call them low-cal homes. And then kind of that was transferred to Canada, saying we can use these passive building strategies and reduce our heating load. We know we can do that. And then these strategies were taken to Germany, and a really important thing happened where they quantified targets to actually invest in passive strategies to meet certain performance targets. And that's the Passive House Institute in Darmstadt that set pass-fail targets for Germany. And then we as Phius applied these targets outside the US, learning some lessons about the US climate versus Germany. And we've now on our third iteration of cost optimized targets for North America. So there's lots of Passive House Institutes. You can see at the top, this is our old logo, Passive House Institute US to Phius, but there's different Passive House Institutes across the world that are adapting to different climates or different cultural norms and things like that. They don't all have their own standards, but there are many different, flavors of Passive House, but they're all rooted in the same concepts. And these are those concepts. So passive building is really defined by three primary control strategies. You have thermal control, radiation control, and air control. Thermal control is achieved through continuous insulation and minimizing thermal bridging. So this is really like putting a sweater on your building, right? And not the same size sweater in every climate. You don't always need a sweater in Miami versus, Alaska, different sweaters. And minimizing thermal bridging. So really paying attention to the connection points and details in the building that might have extra heat transfer and mitigating that through thoughtful design. Radiation control is achieved through optimizing windows and solar gain. So a lot of people think passive house is passive solar. I want to make sure you understand that there's a large difference. We're not just relying on the sun to heat the building. We're not just trying to get all the solar gains. It's not all about that. It's about optimizing, getting solar gains when you want them and blocking or avoiding them when you don't. So optimizing solar gains in the building, as well as optimizing window performance. Air control is achieved through two of the main principles: airtight construction, so really sealing up the building. This is primarily driven by durability in the building. but also potential for a lot of energy savings in places like Chicago, where I'm at. And then alongside airtight construction, we now place intentional openings in the enclosure and provide balanced ventilation with heat recovery. So you seal up the whole enclosure. Now your fresh air is coming in through a centralized filtered location, which provides really good indoor air quality for the building. And then the heat recovery portion is really critical for ensuring that this doesn't, create a large load on the mechanical system. So if you have this continuous balanced ventilation coming into the building, depending on the outdoor temperature, you want to make sure you provide heat recovery so that you're not just creating a large heating or cooling load. And that's another passive measure. And then kind of as a result of these control strategies, you end up with needing lower sized heating and cooling equipment. So minimized equipment, and you can provide high performance equipment, and often something not easily quantified is that you can reduce the amount of distribution networks you need for the heating and cooling equipment as well. So whereas in most typical construction, you might bring heating or cooling out to a window or something. Now that you have these high performance windows, you don't have this drafty area, right? So you can reduce distribution networks required to distribute heating and cooling. Okay, so we're going to look at kind of like a series of questions here when talking about the standard. So the first kind of thing is, how do we set targets for investment in these measures and ensure quality building? So we know we can apply passive building measures to any building and save energy, right? How do we set targets for how far we go with that and ensure quality building? And that's kind of how we landed at the Phiat Standard. So climate specific standard, prioritizing these principles, guiding people, builders, designers to the success in construction of high performance buildings. Again, on this path to zero, a framework to zero energy building. This is how far you should go in conservation